Hey Jags, okay, let's go ahead and finish out this conversation on changing states of matter. When we were inside, we were dealing with boiling waters. We were dealing with temperatures of 212 degrees. It ain't 212 degrees out here, okay? I'd be a whole lot more uncomfortable now if it was that high. It's only around 88 degrees out here, okay? That's not hot enough for water to boil, but it is hot enough for water to evaporate. And that's what happened to the water on this sidewalk. It was a process called evaporation. Now let me go ahead and review that process. I take water. I pour it on the sidewalk. This water is not being hit by energy from an oven, but it is being hit by energy from the sun. Okay? The sun, however, is only able to really give us energy to the water molecules on the very surface. Those molecules at the very top, they're being hit by energy from that big ball of gas and fire up there. And they're sucking up that energy and they're leaving. They're out of here. Well, when that layer takes off, the layer underneath, well, that energy, that molecule, those molecules at the very top, they are now able to get energy from the sun. And then bam, they take off. Well, when they take off, the layer beneath them is now the top layer, and you see where I'm going on this. Layer by layer by layer, all the water molecules collect energy from the sun, and they're able to be changed from their liquid state to a gas state. Again, that process is called evaporation. You do not need 212 degrees. All you really need is any temperature that's above 32 degrees. And this would be a great experiment to do in the wintertime. Because see, right now, you can believe me that it's hot enough out here at 88 degrees for water to evaporate. But what would happen to water on the same sidewalk if it was 34, 35, 36 degrees? That's cold, but yet theoretically that's still warm enough, especially if the sun's up. That's still warm enough for this water to evaporate. So maybe later on in this school year we'll revisit this same experiment. But for now, we talked about boiling inside in the kitchen. We talked about evaporation out here. The big thing you need to remember between the two of them: boiling, the entire collection of molecules is being hit by energy. They're all going from the liquid to a gas. And evaporation, just that surface, those molecules at the very top, they're the only ones get the energy, and they're the only ones leaving. But when they leave, that next layer gets to get it, and then so forth and so forth. So, hey, I'm glad y'all joined me. This was a cool experiment. It's a beautiful day. So let's go ahead and ninja chop, and let's get out of here, and I'll see y'all later.